let's take a look at this question. We're going to be finding the real zeros of the function f of x equals 3x cubed plus 8x squared minus 7x minus 12. And we want to go ahead and write this polynomial in factored form. So the first thing we're going to do is take a look at the degree of our polynomial. And you want to make sure your polynomial is in descending order with regard to your exponents. And you'll notice that our largest exponent on this polynomial is a 3. And that gives us some important information. It means we're going to be looking for a total of 3 zeros, or 3 x-intercepts. And when we go to write this in factored form, right, we know we're going to have 3 sets of parentheses. Each one of these sets of parentheses is going to read x minus one of our zeros. Right? And one of those zeros might repeat, that would be okay. We just need to make sure that we account for all 3 of the zeros. So the first thing we're going to do is we're going to use the rational zeros theorem, and we're going to take a look at the potential zeros that we're working with. And we're going to be looking at 2 values here. The first one is going to be a value that we're going to call p, which is going to be the constant, so in this case, the 12. And we want to go ahead and list the factors of 12, so the things that multiply together to give us 12, which in this case will be 1 and 12, 2 times 6, and 3 times 4. The other value that we're going to be working with is our leading coefficient. We're going to call that q. So in this case, we're looking at the 3 that's all the way out in front. And we want to go ahead and list the factors of 3, which in this case are just going to be 1 and 3. And we're going to be taking these factors and we're going to be listing our potential zeros. And those are going to be in the form p over q. So this is going to end up being our potential zeros list. And I'll go ahead and write this out the long way. We want each of these values for p over each of our values for q. So let's go ahead and take each of the values for p and we're going to write them over 1 as fractions. So I've got 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1. Okay, I'm going to do the same thing, each of the values for p, and this time I'm going to write them over the factor of 3. So I've got 1 over 3, 2 over 3. The next one's going to be 3 over 3, which I already have accounted for. It's already a 1 over here. I'm going to go ahead and list it out. We'll simplify this list after we're done. I've got 4 over 3, 6 over 3. Really, it's the same thing as 2, which is already on my list, and 12 over 3, which also divides out to be a 4, which is already on my list. So let's go ahead and consolidate this list a little bit. We've got p over q. And we don't just have the positive versions of these, we have both the positive and the negative versions of them. So I'm going to go ahead and list them as one big set here. Each of these first values just gives me those numbers right back once I divide each one of those by 1. I've got 1, 2, 3, 4, 6, and 12. And then I've got 1/3, 2/3, right? We already counted for this 3 over 3, that's the same thing as 1. I've got 4/3, and 6/3 is the same thing as 2, and 12/3 is the same thing as 4, and those are already on my list. So here's our list of potential zeros. Make sure you have both the positive and the negative versions for those. Our next step is going to be to go ahead and graph the function, and you can graph this in Desmos. We want to take a look at the graph itself and see if we can take our potential zeros list, and we want to narrow it down to find the actual zeros. So we're looking for where it's going to touch or cross our x-axis. And I have it graphed for us here on the screen, and we can take a look at some numbers here. It looks like at -3 and -1, it definitely crosses our graph. And then we have this one spot over here, which looks like it's a value somewhere between 1 and 2. And if we take a look at our potential zeros list, the only value up there that we have between 1 and 2 would be the 4/3. So it looks like we're going to be working with these 3 zeros. -3, -1, and 4/3. Once we've identified our zeros off of our graph, we're going to go ahead and run each of those zeros through synthetic division so that we can prove it really is a 0. We're going to be looking for a remainder of 0 each time we do the synthetic division. And it doesn't matter which 0 you start with. I'm going to go ahead and start with the -1. Let's go ahead and set up our synthetic division here. We want our coefficients of 3, 8, -7, and -12. And I'm going to start with a 0 of -1. Like I said, you can start with whichever one you want. And after our round of synthetic division here, we're going to be looking for a remainder of 0. That tells us that we're doing it correctly. So let's go ahead and drop down our 3. And let's go ahead and do our synthetic division. We've got -1 times 3, which would be -3. Remember, we're going to be adding at this stage. Add straight up and down, we're going to get 5. We'll multiply to get -5. When we add straight up and down, we get a -12. And if we multiply here, we'll get a +12. And we add straight up and down to get 0. And that's what we wanted. Right? So it divides out evenly. We know that -1 is a 0. When we go to actually write our polynomial in factored form, right, we actually have one set of parentheses now. We can write it as x minus the -1. Keep in mind when you write that inside the parentheses, that'll make it an x plus 1 for our first set of parentheses there. Right? And we want to go ahead and use synthetic division to reduce down this polynomial. When you go to check your next round of zeros, do not go back to the original. You can go ahead and work from your last line on your table. So I'm going to go ahead and use the -3, and I'm just going to go ahead and use my synthetic division table here and start another round of synthetic division. So my next 0 I want to test is that -3. We're going to be working from our answer here. You can always build yourself a new synthetic division piece using that answer if you want to. We'll go ahead and drop down our 3 to start it. And we'll multiply. -3 times 3 is a -9. When we add straight up and down, we're going to get -4. We'll multiply here to get +12. And when we add straight up and down, we're going to get 0. And that's what we were looking for. We wanted it to divide out evenly. Right, so we've proved that -3 is a 0. We can go ahead and put it in our next set of parentheses up here. Remember, it's going to read x minus your 0, so x minus a -3, which will make it an x plus 3. Right? And your last set of parentheses, remember we're going to have 3 sets because our degree was 3. You can actually use this line, your last line here, with the -4 and the 3 that you had to build your last factor, right? That's going to be a 3x minus 4. So you can go ahead and use that if you want to. But I'm going to go ahead and do my last round here with my last 0 using synthetic division. So let's go ahead and run the 4/3 through, since we haven't done one with a fraction yet. And this is our last 0. And you'll set this up the same way, right? We can drop down our 3. And we'll go ahead and multiply here. 4/3 times 3 is going to give us a +4. And if we add straight up and down, we're going to get 0. And for our last step here, we wanted to go ahead and write our polynomial in factored form. So this was the same thing as x plus 3. We had the x plus 1. And you had 3x minus 4. Keep in mind you actually have a couple different ways you can write this. Right? You'll remember from that last round of synthetic division, we had these factors, the x plus 3, the x plus 1, and our other 0 over here was this 4/3. So sometimes I'll have a student that wants to write this as x minus 4/3, right? Because that was our third 0 that we were working with. And the question I always get is, are these two answers the same? The answer there is no, so kind of be cautious. These are actually two different polynomials if you actually expand them all the way out. Keep in mind that if you are choosing to write your answer using this format, where you're going to write it as x minus the 0, and that last one was a fraction, in this case you have to make sure you account for the number that should appear all the way out in front, right? Our first term was a 3x cubed, and if you look at this form, we can multiply x times 3x, right? And that gives us that 3x cubed. If we did the same thing down here and multiplied x times x times x, we only have x cubed, and we're missing the 3. Okay, and so I get a lot of questions as, where does that 3 come from? The 3 that you're looking for in this case actually comes from right here. Right, that was the last piece on your remaining line. So that's the number that's going to become the coefficient all the way out in front when you use the fraction as a 0. So to make these equivalent answers, we'll go ahead and put that 3 out in front. So either one of these two answers would be sufficient for writing your polynomial in factored form.